Hello, welcome back to Science Interactive Notebook class. Today we are going to start our look at some properties of physics, and today we're going to be looking at speed and energy. So we're actually going to be doing something a little bit different than we would normally do with this, because we're going to set up today we're going to set up an experiment, and then I'm going to also put a video here of how you can conduct that experiment at home using some toys you might have laying around. Okay, but first with this today, or the first part of this, we'll be actually making the booklet where we'll be taking our notes in. Okay, so that's what we're going to do right now. Okay, so the things that you're going to want to make sure you have are your Science Interactive Notebook, a pen or a pencil to take notes, your glue stick, some scissors, and some colors if you want them. Those might come in handy a little bit later, but you may want to keep those handy as we go. Alright, so the other thing you're going to need besides your interactive notebook and all those things, all those materials, is this set of pages. Okay, it says Speed and Energy Investigation. Alright, because an investigation is like a deeper look into, and in this case the deeper look into will be a little experiment we are going to set up. Alright, so the first two pages tell us how to do that. Okay, you can put those aside for now because that's what this video is for. You can take a look at those if you want, but that's what we'll be covering in this video. Alright, so the two pages that we're going to actually be working with today are this one with this little card and this one. Okay, and we're going to make a booklet out of this. So that's what we're going to do. The first thing we're actually going to do with this before we even open our notebook today is we are going to prepare this by taking the second page, this one right here that has materials and data graph at the top. We're going to flip it over. Okay, when I flip it over, I just flip it straight across. Okay, I don't want to flip it over that way, and you'll see why. So we're going to flip it straight across, and then we're going to lay this page on top of it. And what I want to do is make sort of like a sandwich with this. Okay, think of it. That's how I like to think of it. Okay, so that when I flip it over, notice that the two blank sides are now touching together. And I flip it over and I have the other page here. The reason that I want to do that is because when I fold it to put it into my notebook, I'm going to fold it like this in half, right? Again, like a sandwich. And then when I flip through it, notice that the inside pages will open up just like a book. Okay? And then in order to, the other way to achieve this is that I'm actually going to glue these blank sides together. So once I have my pages laid out, again back to back, so the blank pages are touching. Now what I'm going to do is I'm going to put glue all over the blank sides here. I want to glue those blank sides together. Don't be afraid to use a lot of glue for this. Okay, how I'm doing that is I'm going to, the easiest way I found is to glue half of it first, smooth it out, and then lift up the other half. This makes it, I think, easier to actually keep the pages in alignment so that when I lay them down that they lay nice and flush together. Okay. There we go. Make sure you get all the paper there. And then smooth it down. And then what you should have now is a cool double-sided page, right? Now the pages are stuck together. The blank sides are glued together. So it is a nice little double-sided page like that. And then of course when I fold it over, now you can see that when I open it up, it's like a little booklet. Cool. And then I still have a blank side, and this blank side is actually going to be what I glue into my notebook, okay? You may want to let that dry for a minute though, just to make sure it is going to stick. Make sure you don't need to put any glue anywhere else, okay? So as I do that, fold it over, and as you let it dry, this could be a good time that you get out those colors. If you want to color your car up here. And as I color the car, I can read the question. This will be the front page. So again, we're looking at speed and energy. We're going to investigate that with this little experiment of ours. So the question, anytime we have an investigation, anytime we conduct an experiment, we always start with a guiding question, okay? A question that we're trying to answer. So let me zoom in on that a little bit here. And our question is, does a car have more energy when rolling down a 5 centimeter tall ramp or a 10 centimeter tall ramp? Okay. So, grab one more thing. Now, obviously, 5 centimeters tall is shorter than 10 centimeters tall, correct? So, and 10 centimeters is actually double the height of 5 centimeters, right? It's twice as tall. So we're just going to decide which one has more energy. When the car is higher up and rolling down, or when it is lower, right? So at 5 centimeters, when it's lower down a ramp, it has a lower distance to go to the bottom, or when it has a higher distance to go to the bottom. When does it have more energy? What's good about this is it kind of ties into what we were doing with Sciences Elementary before we started winter break, if you remember that. We looked at inertia and some of the laws of motion. So this is continuing that. Okay, so now that I've had a chance to let that glue together, I'm ready to glue this into my Sciences Elementary, or sorry, my Science Interactive notebook. I got confused. So what I'll do is I'm going to open up to the next blank page. So if you've been working along with us, you'll see the last page we did was hydroelectric energy. That was on page, what's that down here? Page 11. I'm going to flip that over, and I'm going to glue this here, and you can see it should fit just perfect in there. I'm going to glue it right under the top line into my notebook, and this will be page...
I have to go potty.
Okay, go potty. Go potty. So this will be page 12. Okay, so on the bottom of this, I'm going to put page 12.
You're doing that.
Go potty. Bye, go potty. Okay, so this is page 12. I'm going to glue this in here. When I flip it over, I'm going to glue the whole back. A lot of glue because this one's going to be, since it's 2 pages put together, it's a little bit heavier. Okay. Glue that in there, and then I'm going to title this. And I'm going to title it at the top, speed and energy. Okay. So now I have my booklet glued in up top. And again, with all these, you could pause as you need to if you're if I'm going a little fast. Make sure you pause. You could also rewind. All right, so I have speed and energy, and I have my new booklet glued in. See, as I open it, I have all 3 pages that I'm going to use for this investigation. Let's go through the booklet now and see what it says, because this booklet will take us through what we like to call the scientific process. Okay? Scientific process is the way that scientists approach any problem, any scientific problem. Okay? And the first thing, like we talked about, the first thing that you do in the scientific process is you pose a question, right? Or you have a question that you want answered. So the question that we have here is, does a car have more energy when rolling down a 5 centimeter tall ramp or a 10 centimeter tall ramp? Or basically, it's a rephrasing of the question, does a car have more energy if it's rolling from a higher hill or a lower hill? And we just picked these two measurements for ramps because those are going to be easy for us to construct into a test later on. All right, so that's our question. Our hypothesis. Hypothesis, we're going to stress every time we say the word hypothesis, we're going to think of the phrase an educated guess. Okay? So it is a guess, but we call it an educated guess, which means we're not just saying the first thing that comes to our head, right? Educated guess means you take some time and you think about it and you use what you've learned before. So if you recall the experiment that we saw with the dominoes, if you recall looking at the roller coasters and how the two different types of energy work with running a roller coaster, you have potential energy, you have kinetic energy. Remember, potential energy is stored energy, kinetic energy is moving energy. So if you take those things, you recall those, and you see how you can apply those to our problem, then you start to come up with an educated guess. And the reason you want it to be educated, which just means thoughtful or reasoned guess, the reason you want that is because you're going to use this hypothesis to create a plan, which will be the way that you test your guess. Okay? So for this, let's think about it for a second. Do I think that the car will have more energy when rolling down a 5 centimeter tall ramp or have more energy on a 10 centimeter tall ramp? Well, thinking back to those roller coasters, and also my experience of being on a roller coaster, it seems like you move faster when you're going down a larger hill, right? It seems like when you're higher up off the ground, you have more potential energy, and there's more gravitational force that's pulling you down, which means you're going to go faster. So it seems like you're going to have more energy at a higher ramp. So that's going to be my guess. If you have a different guess, that's fine. You could put, if you think it's going to be 5 centimeters tall, you can put that here too. You don't have to copy mine exactly. But I am going to guess that it's going to have more energy at the higher ramp. So I'm going to write this just like I would answer any essay question in a complete sentence. Okay, and the more information I can put into this, the easier it's going to be to design a test later on. All right. So if a toy car rolls, okay, so here's what I say. Does a car have more energy when rolling down a 5 centimeter tall ramp or a 10 centimeter tall ramp? I'm going to say a car will have more energy when rolling down a 10 centimeter tall ramp. Okay, now that's a good answer to the question. Again, it's a guess because we haven't done it yet, so I don't know for sure. That's why it's a guess, but it's an educated guess because I've used what I know about energy so far, potential and kinetic, and what I know about gravity. So it's a good one, but it's not a great one. How do I make this a great answer? I offer an explanation. And in science, I always want to try to make the best answer I can, so I try to explain even in my hypothesis. So how do I show an explanation? With the word because. Right? That'll explain why I think this. So a car will have more energy when rolling down a 10 centimeter tall ramp because it will have more gravitational force on it, right? The higher up it is, the more gravitational force is pulling it down. And the more chance for gravity to work pulling it down. So it'll build up more energy, more of that kinetic energy as it moves. Okay, so that's my hypothesis or educated guess. All right, now you can see that there is a plan that it lays out, which is going to be how we can test out our hypotheses. Okay, so what this is going to give you a plan that you can do this on your own at home. And I'm going to also put a video that will go along with this one of somebody else constructing this, because they do a really good job of it. I think better than I could do. So you can follow that along at home. Okay, but what you will probably need, and maybe you can find this at home, is some sort of straight thing. And actually, if you look in, what would be perfect is if you get your science is elementary kit. We have most of the stuff in here that you could use. Okay, so actually you could use this to make your ramp, because you can use this piece of cardboard. So you could use this. Let me zoom out a little bit. So you could use your cardboard from your science kit.
What color did you pick?
And there's also a ruler in there too you could use. And if you notice, the ruler will help you because it has the centimeters already. So it'll show you how high to set your ramp. So the first one will be 5 centimeters tall. So if you put it on the ground, you can measure up 5 centimeters. And then the second one will be 10 centimeters.
Why are you doing that?
And that's how you'll set the height. Thank you, Judge. Okay. Sorry, I got my helper here. You can hear him in the background. Okay. So that's some materials you can use. If you have a toy car, maybe you have one, maybe a younger brother or sister has one laying around. You can use that. If not,
why did you pick up a car?
you have the marbles in here, and you can also use the marbles because they roll. So they just don't roll as well. I mean, they roll well. They just, or you could even use the little ball that came with it. So you could use that stuff if you don't have a car. Okay, so that's what you're going to use to construct your ramp. And again, I'm going to put a video up here that goes through that a little bit better to show you how you can use those, but those are materials that you can use. Okay. The last thing we're going to do in here, and then I will let you go to do the experiment, and then we'll talk about it probably in one of our later classes this week to review. But I want to make sure I give you guys a chance to practice this. So what you're going to need is your cardboard or something else that you could use to make a ramp. Maybe even have a toy ramp at home. That works too, right? You're going to make it at 5 centimeters tall, and you're going to make it at 10 centimeters tall. A toy car, but again, it could be that one of the marbles or the ball that comes in your sciences elementary kit. You're going to need your ruler, okay, and a stopwatch, but you could also use your phone for that, right? Because your phone has a stopwatch feature. And that's just to time the difference that it takes for the car or the ball or the marbles to roll down your ramp. Okay, the last thing though I want to fill out with you guys before you can start is the variables, okay? So the first variable is what we call an independent variable. The I got cut off here, okay? So it says independent. An independent variable is the thing in the experiment that, or in your plan that you control. It's the thing that you can change, okay? So in this case, since I'm testing it at 2 different heights, one ramp is at 5 centimeters and one ramp is at 10 centimeters. That means the thing that's changing is how high the ramps are set, okay? And I have control over that. That's what I am changing, okay? So we'll say that the ramp height is the independent variable. Now dependent is the thing that changes because of the difference here. So it's what will change in my experiment depending on how high the ramp is set. And that's what I don't control. That's going to be controlled by my toy car or my ball or the marble or whatever it is that I'm rolling and how long it takes to get down or how far it goes. So the variable here, the thing that's going to change, is actually what I'm going to be measuring. And what I'm going to be measuring is the distance traveled. Okay, distance traveled. And usually in science, whenever I'm measuring something, I put the units that I'm measuring it in. So in this case, it'll be in seconds. Okay. SEC period is the abbreviation for seconds. Now, the control, the things that I can control, or the things that are controlled during the experiment are just the things that I'm setting up. So for instance, it'll be that I'm going to use, if I'm using the toy car, I'm going to use the same car at both heights. I'm not going to change it from the car to the ball. If I'm using the ball, I'm only going to use the ball. So I use the same, I'm using the same thing here, right? Either the car or the ball, but that's going to stay the same. So the same car for this case. The other thing will be that I'm going to use the same material for the ramp. So I'm going to use this cardboard for the ramp. So same ramp material, whatever that is. That's going to stay the same for both ramps. Okay. And the reason that is I want to change as little as possible. The only thing that I want changing is how tall the ramp is. I don't want anything else changing in my experiment, or else that affects the outcome. Then the last thing will be the surface. So if I do it on my table, if I do the 5 centimeter tall ramp on my table, I do the 10 centimeter tall ramp on my table. If I do the 5 centimeter tall ramp on the floor, I do the 10 centimeter ramp on the floor. So the surface will be the same too. Okay? So those are things you want to copy down in. And then the last thing that we are going to fill in here will be what you're actually going to be testing. Distance, the toy car, or if you're using the marble or the ball, you can switch that with their travels. Again, this is in seconds. Okay? So again, what I wrote here, what I'm measuring is my dependent variable. It's the same thing, distance traveled, distance travels. Okay? And I'm going to do 3 trials at both heights. So when I make my 5 centimeter tall ramp, I measure how far my car travels. And then when I raise it up higher, I measure how far it travels after that. Okay? And then you'll use your handy dandy ruler to measure how far the car travels. Again, watch the video that I'm going to put on here to help you set that up. All right? Very cool. Then, when all's done, right, when you've done it 6 times, 3 with the 5 centimeter tall ramp, 3 with the 10 centimeter tall ramp, we're going to show you how to do a graph, okay? We'll do this one together later, okay? And then we'll come up with a conclusion. All right, but I hope that you try this out. And again, I'm going to put a video up to help you guys see how to do it, but hopefully you're able to copy this into your notebook, all right? Okay. Well, with that, we're done for now. Once you've done this part, then I encourage you to do the actual investigation on your own. Watching the video, set up a ramp, roll a car down, measure how long the car travels. Okay? All right. I will see you guys next time. Great job.